we'll go through page 6, permutation. Actually, before go through, yeah, permutation. Okay, so I'm going to ask the student to tell me how to do example 4. How many arrangement of 2 letters are possible from 26 English alphabets if no repetition is allowed? I'm going to ask William. Example 4 on page 6. Have a think. Just tell me what you think the correct answer is. So how, yeah. Twenty 25 times 24. Okay, explain each bit. So 25 is there are 20, I think there's 26 alphabet. So you mean 26 and then times 25. Okay, I think that's right. We'll just double check on our calculator. So let's use the calculator. 26 times 25 does give you 650. Okay, that's correct. So there's 26 ways to choose the first letter, 25 ways to choose the second letter. Therefore, there's 650 ways altogether. Okay, that's pretty okay. Let me ask another student. Let's ask Jessica C. Okay, Jessica C, can you tell me how to do example 6? How many ways of arranging 5 people on a line? 5 factorial. Okay, good answer. Okay, 120. That's on the calculator. You know how to access 5 factorial, which is 120. Okay, good. All right, let's do more questions. Looks like you're pretty good at it, so we're going to continue. How about the next question example? I'll go through the, okay, permutation notation. So 5p1 means 5. 5p2 means 5 times 4. So the bottom number tells you how many numbers there are. So 5p3 will be 5 times 4 times 3. 5p4 will be 5 times 4 times 3 times 2. So this number tells you how many numbers here. There's 4 numbers, okay? And this is 5p5 means 5 times 4 times 3 times 2 times 1, which is same as 5 factorial. So this has more flexibility because you get to choose how many numbers to put down, okay? All right. And there's a calculator button for the P, which you probably know already. So if I want to do 5p3, you go 5, shift times, isn't it? Shift times is the P. 5p3, we get 60. So that will be 60. Okay. All right. What else are there? Okay. All right. I think they are pretty easy. So, for example, if I want to do example 11, if there are 20 cards, 13 cards are chosen in order without replacement, find the possible number of ways the cards can be chosen. So, I would have to do 20 times 19 times 18 ... 13 numbers, isn't it? 13 numbers, which will take you a long time to type. So you just do 20p13 on your calculator, which is a very big number. 20 shift p shift times 13, which is a massive number. Okay, so we're not going to get into that. So you know that's the answer. Okay, that's how many ways of rearranging 13 cards from 20 cards. Okay, good. Now, is there algebraic formula for this? In fact, there is. So let's do this. So NPR means n times n minus 1 times n minus 2, ... And there are R numbers. There are R numbers. So therefore, the last one will be n minus R plus 1. Okay. Now, this is not a very convenient form. Let's express it in terms of factorial. So in terms of a factorial, you multiply by the remaining stuff. So you times it by R factorial, times it by R times R minus 1, ... 2 times 1, over times by R times R minus 1, ... 2 times 1. So therefore, this is exactly R factorial. So the top bit will become n factorial because n minus 1 all the way to this. This just joins. That's the next number over R. Over, I think I made a mistake. R factorial. Actually, it's not R. So you're not meant to times by R. Sorry about that. Okay, I think I made a mistake. So you have to times it by, the next one will be n minus r. That's right. And then n minus r minus 1, dot, 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 up to 2 times 1. And times by n minus r minus 1, dot, 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 2 times 1, which is exactly n minus r factorial, and then n factorial on the top. Okay, so that's the formula for NPR. Okay, we should highlight this. Where's the highlighter? Highlight. Okay, alright, green and yellow. Okay, alright. Okay, so you should memorize it. It's not on the formula sheet. Okay, alright, after we do this, let's do the next question. Let me ask another student. Let me ask L, example 12, how many ways can 2 dice fall? Twelve ways? Okay, 12 ways, maybe 6 plus 6. Okay, alright. So for 2 dice, yep. Alright, oh, do you have another answer? Oh, okay. 12 factorial. Okay, 12 factorial, maybe. Okay, alright. So in this topic, it's very important we don't overuse formulas, because let's look at how it works. 2 dice fall, what are the possibilities? Well, when for 2 dice, it could be 1, 1, could be 1, 2, up to 1, 6, or could be 2, 1, 2, 2, 2, 6. Now, if we look at this, how many ways altogether? 36. So it's actually 6 times 6. So the factorial and the p doesn't always work. So it's very important that we don't overuse this. So the answer will be, ways will be 6 times 6 ways, because there are 6 ways the first die could get the answer. There are 6 ways for the second die. So therefore the total ways is 36. Okay, good. So 36. Alright, so it's very important that in this topic we do not overuse any formula. Now, this comes back to the comment I have on page 2. If you go back to page 2, which is this bit here, because we are accustomed to doing differentiation, every time we see a function, we just go, okay, that's the formula, dy over dx is 3x squared. Okay? Now, in this topic, we need to avoid using formula every time and read each question very carefully and analyze them very in detail. So let's do more questions. So let's do more. Okay, example 13, let me ask you. Another student, Megan, what's your answer for this question? Page 30, say again? Yeah, but you got to explain. That's the whole point. Explain, it's not just the answer, it's how you do the question. Example 13 on page 8. 7C2. Okay, now arrangement will not be doing selection. That's the order is important. So you say, how many ways can 4 women and 3 men needs to select a captain and vice captain? So what we do is we'll find how many ways for the first person could be selected. So how many choices for the first person? 7 choices. So you got 7. How many choices for the second person? 6 choices. So altogether there are 42 ways. Okay, good. All right, so we're going to do more questions. So it can be confusing. All right, let me see. Now that means I should go through the first page. Sorry about jumping around things. So we'll go back to the first page where I have very things in detail. Let's look at the basic counting. I think that's too easy. Okay, all right. All right, let's look at this question. Example, where's this page? This is on page 4. All right, go to page 4. How many ways can 2-digit numbers are possible from the digit 1, 2, 3, 4, 5 up to 9 if repetition is allowed? Notice that I gave you a lot of space to list the outcomes. So repetitions allowed, so if you list them, so it could be 1, 1, 1, 2, 1, 3, all the way to 1, 9, and then 2, 1, 2, 2, 2, 3, up to 2, 9, and then you can go all the way to 9, 1, 9, 2, 9, 3, up to 9, 9. So clearly, there are 10 times 9 times 9 ways, isn't it? Which is 81. But we're not going to list that every time. We're going to fill this sentence. How it works is this. For each first digit I've chosen the first digit. There are 9 ways. There are 9 possible ways for each first digit I chose to choose the second digit. Since there are 9 ways to choose the first digit, the total number of ways will be 9 times 9, which is 81. So think about this sentence very carefully. And this is the way we think about this topic. Okay, is to think about the choices for each part rather than use formula. Okay, so be very careful when you use a formula because they may not be correct. Okay, so let's read it again very carefully. So you say, for each first digit I choose, there are 9 digits, because see, if I choose 1, there are 9 choices. If I choose 2, there's also 9 choices. And because there are 9 choices for the first digit, therefore the total number of ways is 9 times 9. Okay? Alright, so now we can generalize this to the next problem. What if repetition is not allowed? Same thing. There's 1, but you can't choose 1, will be 2. 1, 3, 1, 4, up to 1, 9. Okay? And then the next one will be 2, 1, 2, 2, but you can't have 2, 2, so it will be 2, 3, up to 2, 9. But for each case, there are 8 choices, isn't it? There are 8 choices here, and there are 9 choices, because you can do all the way to 9, 1, 9, 2, up to 9, 8. Okay? So therefore, for this one, for each first digit I chose, there are 8 choices, because 8 possible ways to choose the second digit. Because it doesn't matter whether I choose 1 or 2 or 9, there's always 8 choices, because you have 1 choice left. You can't choose the digit again. But since there are 9 choices to choose the first digit, the total number of ways will be 9 times 8, which is 72 ways. Okay, so you don't have to list the outcome each time. But if you can't see it, list the outcomes. Alright, so hopefully it's more clear. Let's do one more question. After you fill this out, we'll go to the next page. What is 3-digit? You're not going to list all the 3 digits because that will be very difficult. It'll be 3-dimensional because you have to list them on this level, and then it's going to be a cube, isn't it? So, and what is 4-digit? That will be 4-dimensional. It will be too difficult to imagine. So what you're going to do is to do it this way. Okay, it's good. So how many choices? So repetition allowed. So you got the first digit, second digit, third digit. Remember, repetitions allowed. So there are 9 choices for the first digit. Once you chose the first digit, there's still 9 choices left for the second digit, and there's still 9 choices left for the third digit. The number way will be 9 cubed. I think 729. Let's double check that. 9 cubed. Yep. Okay, good. Ways. Okay, so you do it this way each time. Do not overuse factorial or P or C, whatever. You've got to read the question each time. What if the repetition is not allowed? What's the probability of choosing 123? So in that case, there's 9 choices for the first digit. Let's write it 9 choices, first digit. But once I made a choice, I've only got 8 choices left. 8 choices for each choice. For each choice I made for the first digit. For the first digit. Because once I chose the first digit, there's always 8 choices. That's why I times by 8. And once I chose 2 digits, there's only 7 choices left. So therefore, the answer will be, so you just learn 8, 9, P3. So you only write this down first, and you see this is consecutive. Before concluding, you can use 9P3. Do not go to 9P3 straight away. Okay, so you go 9P3, shift P3 equal 504. Okay, so do this reasoning first before you say, oh, that looks like it's P, so you do the P. Okay, all right, and then probability of choosing 1, 2, 3 is just simply 1 out of 504. Okay, done. Okay, we're not going to do everything. I've got all the video which shows you all the questions, so we're going to move on to some other questions. Let me see if there's good questions. Okay, let's move on to question 14. All right. All right, question 14. So on page 8. Okay, how many ways can 3 people be arranged in 4 seats? Who want to have a try? Yep, Mitchell. Yeah, but you've got to tell me how you do it. All right, you have to explain why is it 4p3? How does it work? Okay, in terms of this, 4 seats, you pick 3. Okay. Yeah, okay, let me think. So in terms of the reasoning, but how about the next one? Would the 7p5, yeah, it should work. All right, okay, good. So you do 4p3, but we've got to see why is it 4p3. So in this case, it's better to have the people choose the seat. So there are 3 people which have A, B, C. The first person will have 4 choices. The next person will have 3 choices. The next person will have 2 choices. Yeah, so therefore it's 24. Okay, so you have the people choose the seat. And the next person, there are 5 people, 7 seats, so you have the people choose the seat. So the first person will have 7 choices. The next person will have 6 choices. And the last person, you have how many seats left? There are 3 seats left, which is just 7p5. Yep, okay, good. So you do it on a calculator, 7p5, 7p5, you get 250. Okay, so it's correct. How about 16? Who want to try 16? Have a think? All right, have a think. All right, Jacob, have you done it? Example 16. Prefer you not to try all the possible ways so you can calculate 625 and apply reasoning. Yeah, you. H, yeah. Yeah, did you do 16? Have a try. All right, I'll give you another minute, or anyone else who want to tell me how to do 16. And you have to give me a reason. Me, if I tell the answer. All right, Mitchell, go. Explain. 20 rooms, yep. No, there's only 5 rooms. Yeah. 4 people going to 5 rooms. Yep, 20 spaces, yep. Yep. Oh, that's a cool way. Does it work? Never thought of that. 20p4. No, it doesn't work. Because, like, it doesn't matter which order, isn't it? Because, yeah. All right. That's a good way to think, but it doesn't work. Not 20p4. Would 20c4 work? Works. 20c4. Also doesn't work because it doesn't. But be careful that one room can only accommodate up to 4 people. So you're assuming that some room can accommodate. Actually, yeah, it doesn't work. All right, who want to tell me? 5. Yeah, did you try everything? Why is it 5 to the power 4? Okay, because more importantly is to see now. If there are 4 people going to 5 rooms, you look at just like the reasoning before. Look at the first person. How many choices does the first person have? 5 choices. He can do any of the 5 rooms. How about the second person? He can go to the same room as the first or a different room. So there are 5 choices. And then the third person will have 5 choices. And the fourth person will have 5 choices. Therefore, it's 625 ways. Okay? Again, my advice, do not overuse P or C because it doesn't always work. Think about the question, okay? All right, good. So that's the difficulty of this topic because the formula doesn't always work. And it's not obvious which formula to use. So you have to use the multiplication principle. Always do it like this, okay? All right, good. After we do this, we're going to continue. Let's look at permutations with conditions. Okay, how many ways can 4-digit even numbers be formed with digits 3, 4, 7, 8 if no digit can be used more than once in a number? It's an even number. So what do we do? If there are restrictions, the even number has to be, the last digit has to be even, which can only be 4 or 8. So there are 2 choices. Once you choose one of these, there are 3 choices for the first digit, 2 choices for the next digit, 1 choice for the third digit. So the total number of ways is 6 times 2, 12 ways. Okay? Again, do not do P, do not do C, it doesn't work. You have to look at each question differently. Okay, next question. How many 4-digit even numbers are possible if repetition is allowed? Okay, I get students to try because it's very similar. All right, who want to try? Jacob R. So how many choices for the last digit? No, again, do it this way. Do not go to factorial straight away because it doesn't always work. All right, tell me. How many choices for the last digit? And how many choices for the first one? No, 4 because repetitions allowed. Okay, how many choices for the next one? 4 again, repetitions allowed. Yeah, see, the factorial doesn't work. Okay, so be very careful. Do not overuse the formula. Only use the formula when you see the pattern that it does fit the formula. If it doesn't, just do it straight away. 128. Okay, good. Next question. How many ways can 4-digit numbers can be formed from digits 1 to given no digits can be repeated? All right, what was, there's a probability. Yeah, let's go through that. Okay, all right. So how many 4-digit numbers given that no digit can be repeated? Okay, all right. So I'm going to ask the students. So have a try. Aaron, 19A. Yep, that's good. No digit can be repeated. 4, 3, 2, 1. And then when you see this, they say, okay, factorial. Don't go factorial straight away. Only after you're confident that's going to be factorial, then you write factorial. Let's try, see if it works. 6 factorial. 8, oh, it doesn't work. Oh, because it's 4-digit number. Oops. So we have to delete this. 3, yeah, so it's 6P4. Should be right. Okay, 6, right? Because he got rid of 2. Yeah, because 360. Okay, good. Next question. If a random selection is made from these 4-digit numbers, find the probability that the number selected is greater than 4,500. So to answer the probability part is find how many numbers are more than 4,500. So the number of ways that could be, so because of the restriction, it has to be greater than 4,500. The number has to start, so we have to do 2 cases. So the cases are, if we start with the digit 5 or 6, so there are 2 choices, right? Start with 5 or 6 for the first digit, and the next digit could be anything. So how many digits left? There are 5 left, 4, 3. Okay, so that will be 10 times 12, which is 120. What if the case 2, that's case 1, what if you start with the digit 4? If you start with the digit 4, you have 1 choices. And if the digit is 4, the next digit has to be 5 or more. So it has to be 5 or 6. So it will be 2 choices. 5 or 6. And then once you choose 5 or 6, the next number could be anything. So it could be how many choices left? There are 4 digits left, and then 3. So therefore, that will be 6 times 4, 24. So total number of ways will be 144. So the probability is greater than 4,500. Will be 144 over the 360. Does it work? Let's see. 144 divided by 360. 2 over 5. Yep, 2 over 5. All right, it works. Okay, any questions? So it can be very tricky. We will also look at more questions with cases as well. Yep. Because if the first digit is 4, yeah, I know, but then the next digit has to be 5 or more. I can't put 1 on the next digit. That's why I have to do a case. So if the first digit is 5 or 6, I don't have to worry about the second digit. But if the first digit is 4, it has to be 5 or 6. That's why I can't do it together. Yeah. Okay, good. Next question. All right, who else have a try? So Dora, the next one, question 20. How many ways for 4 consonant, 3 vowels be arranged in a row if the first and the last places are occupied by consonants? So there are 4 consonants. So there are 7 numbers. Okay, what would you do first? 1, 2, 3, 4, 5, 6, 7. Okay. So how many choices for the last letter? 4 choices because it has to be consonant. How many choices for the first letter? 3. And then how many choices for these letters, for this one? It could be consonant or vowel now. So how many letters left? So 4 and 3, so 5, yes. And next is 4. It doesn't matter if it's vowels or consonant. 3, 2, 1. And then when you see that, oh, that's factorial. So you go 5 factorial and the 3 and 4. Do not jump to factorial straight away until you're confident. Okay? So let's do that on a calculator. 12 times 120, which is 5 factorial, 1440, which is correct. Okay, good. Next question. All right. Okay, let me ask more people. Let me actually separate it. A man has 6 history books. How many choices? Okay, all right, good. All right. Let's skip some questions. Let's go to 22 straight away. 22. How many ways can 6 history books and 4 geography books be arranged? He wants the history books to come first, and then how many possible ways are possible? Okay. All right, so maybe Richie. So what's your way to do? So there are 10 books you have to arrange. You have to go put the history book first. Yep, what's your explanation? Because, yep, and then the geography one, yep, which is 4 times 2 times 3. Yep, very good, good explanation. Geography, and then history. So then you recognize 6 factorial times 4 factorial. I'm not going to do that because it should be the same. Okay, excellent. All right, I'm going to ask if anyone wants to try the next one. Next one, a little bit challenging. 5 boys and 3 girls be arranged in a line if the girls are always to stand separated. Okay, what would you do? All right, give you a minute and then we'll talk about it. And then we're going to stop there, I think, because we can spend all day doing this, but we don't have time. All right. To explain, so how do we get that? Stand separated. So how would you do it normally in real life? So in real life, or maybe, so what you do is, if the girls are separated, it's better to put the boys down first. So let's put 5, 6 down. So how many ways to arrange the boys? So there are 5 factorial ways to arrange boys. Right? So the boys will sit down. And we need to ensure the girls are separated. So where do we put the girls? Either in between or the first or the last. Right? So that means the first girl, G1, G2, G3, the first girl will have how many choices? How many? 1, 2, 3, 4, 5, 6. How many choices for the next girl? 5. How many choices for the next girl? 4. So therefore, the total number of ways will be 5 factorial multiplied by 6p3. And then see if you get the answer. Okay, I'll just stop the video. So every time you see a question with separated, that's what you do. Okay. Let's do. I want to do a few more questions so that because we are running out of time, we don't have many lessons left. So let's move on to the next one. Is this fun? This one's not that fun. This one. Yeah, I'm going to put the video up so you can just watch it later because I've got all of these recorded from last year. They're all the same. I want to do some questions on maybe, this one. On page 12, okay? Let's continue. Page 12. What do we do? How many ways 5 boys and 4 girls can be arranged in a line if the boys and girls alternate? Who want to have a try? On page 12. Example 28. Boys and girls alternate. Yep. Yep. So what would you do? Yep. And then? Yep. But then that's good. X. Yeah. But then let's try whether it works. So did you say 6p4? All right, I don't think it works, but we'll just have a try. 120, which is 5 factorial, 6p4, which is different. Now, why is it different? We've got to be careful here. It says alternate, so strictly speaking, if you're going to separate the girls in such a manner, B, 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 if you just put the girls here, there's a problem. They are not separated. It has to be alternate. So there's a difference between separated and alternate. Yep, go. That's right. The boys has to go first, which has to be. The boys go first, and the girls can only go here. So be very careful with the difference between these two. So in this case, it's just 5 factorial times 4 factorial. And you should get that, okay? So be very careful. How about the next one? Example 29. Who want to try? Otherwise, I pick someone to have a go. Separate groups. Example 29. So in this case, the boys and girls are separated in separate groups. So the boys are together and the girls are together. So how many ways? Joyce? Yep. Yeah. So basically, 5 factorial ways to arrange the boys, 4 factorial, and what did you say again? And what else do you have to do? Yes, because you can swap these, right? So you times it by 2 or 2 factorial. Because if there are 3 groups, you can do 3 factorial. Okay, good. So we're going to do that, and that will be that. Okay, we're not going to do it. Okay, next person. How about 30? This is a good one to do. How many ways can be arranged if the 2 particular girls want to be together? So everyone else can go anywhere, just that 2 girls are best friends, they has to be together. So what do we do? All right, who want to have a try? Mitchell. Yeah, so what do you want to say? Oh yeah, you can draw on the board. Nine for the first, 9 ways. Yeah. Yep. Right. So what does the 9? So the 9 people together, and there are 2 people. But then how do you know where to put the girls, the 2 girls? Because they could be anywhere in the line. All right, no problem. Okay, it's very good try. That's good. That's good. Anyone who want to have a go? Jacob, go. What would you do?
Along the line, together.
Yes. Yes. So you assume the girls are just together, just one person. So two girls are one person. So there are, instead of 9 people, there's 8 factorial. Yep. And then what do you do next? To rearrange the girls. Arrange the 2 particular girls. Yep. Very good. And then just get the answer. Okay, so 8 factorial ways because you assume the 2 girls are one person, and then rearrange the 2 particular girls. Okay, good. I think we've done enough. Have we done enough? I want to do a bit more before we do it. Yeah, we'll just do. Okay, let's finish it. Let's finish up to page 14. I want to do question 32 because that's quite interesting. Okay, how many ways can the letters in pencil be arranged if the letter E is next to the letter I? So yeah, have a try. Okay, while you are trying, I'm going to hopefully have a try. So how many ways can the letter E next to letter I? That's the same question, isn't it? 6 factorial times 2 factorial. You get this, right? Because you assume that E and I are the same object. Okay, next one. What if there are 3 letters between the letter E and letter I? Letter E and letter I, what would you do? That's a little bit complicated. So what you do is this. You go cases E, 1, 2, 3, I. Just did that. Thank you. Thank you. All right, E and I. Okay. There are 3 letters between E and I. How many letters are there? E and I. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. So there are actually 7 letters. So there are, yep, okay, E and I, there are 3 letters. So what other cases are there? E, 1, 2, 3, I, or 1, 2, 3, E, 1, 2, 3, I. Okay? So how many ways here? So the number of ways will be, there's 5 remaining letters. So 5 factorial. There's 5 factorial here. There's 5 factorial there, right? So how many? And you have to add them together. So 5 factorial times 3 cases, but you can also swap them. They just say 3 letters, doesn't say which one goes first. So swap. So that will give you additional 2 double the ways. So how many ways altogether? You should get 720, but let's see if it works. I just remember 5 factorial is 120, so it's faster. Times 3 times 2. 720. Okay, good. See if you can try the next one. And then we'll pack up after this because this one's quite interesting. Letter E precedes letter I. What does that mean? Because it could be E first and then I, or could be E, a gap I, or a gap E, and then I, or gap E, gap I, or 2, 3 gap I. So the E has to go before I. So when you look at it, it looks like there's a lot of possibilities, isn't it? But we can actually account for all the possibilities. So let's try to do that. So you look at the case where there are 3 gaps between them. So what you do is this. You look at the case where there are no gaps. So if there are no gaps, so it's EI. So how many ways? So 1 to 5 factorial times, actually think of together, so it's 6 factorial. 6 factorial and then times 2 because they could be together. And then 1 gap. In that case, you go E, a gap, I, 1, 2, 3. Actually, times by 2, they can't be swapped. 1, 2, 3, 4, 5. So it will be 5 factorial, but you can see there are 1, 2, 3, 4, 5, 6 cases. And then you can do 2 gaps between them. E, 1, 2, 3. 1, 2, 3. Okay, so E can go here. 1, 2, actually no. I could go here, I could go here, I could go there. So there are 4 cases. I think I did the first one wrong. So that should only be 5 cases. So how many? So you get 2 gaps, 3 gaps. And you see the pattern. Each time you increase the gap, there's 1 less choice. And 2 gaps, how many choices? 2, and then a 3, 4 gap, and 5 gap, there's only one choice. So what do you do? It's like doing, this is like doing 5 factorial times 6. So the total number of ways is 5 factorial times 1 plus 2 plus 3 plus 2 up to 6. Use your calculator. You're not going to sum the AP. 2 plus 3 plus 4 plus 5 plus 6 equal times by 5 factorial. It should be right. 2520. Now that's a long way to do that question. In fact, there's a faster way. And the fast way is very fast, very easy to do. Okay, we only got less than a minute. So what's the fast way? Now, if the question say, what if I precedes E? What will your answer be? I precedes E. Have a guess. It should be the same, right? So what does it mean? It means that the total number of ways is 7 factorial. And in all the total ways, it's either going to be, total ways will be either be I precedes E or E precedes I, isn't it? So if you do 7 factorial divided by 2, what would the answer be? 7 factorial divided by 2, you should get the answer 2520. So the next time you see that question, you just do it this way, method 2. Okay? All right, so we're going to continue that tomorrow. Thank you very much. I'll see you then. I'll put up the video so you can watch more and get more work after this. Okay. All right, good. Get back up.